Okay, so this part asks for us to find the speed of the pendulum bob at point A. So what's it doing at point A? You go back and look at the picture. It goes from point B, where it has a speed, to point A, where it has a height. Did the problem tell you that it stopped there? No, so we don't know. It could have. Let's find out. So is there any non-conservative force doing work on this object? There is a non-conservative force in the problem. There is a tension force in the problem, but the tension is acting perpendicular to the position all the time. The tension is up while it's moving to the right at the very bottom. The tension is up and to the left while it's moving tangent to the circle. So the tension is always perpendicular to the change in position, so there's no work being done by that tension force, that non-conservative force. So when there's no non-conservative forces doing work on an object, where do we start? Yeah, E naught is equal to E. So for our pendulum question, okay, so down here, it's moving, and then up here, at this other position, it's doing something. We found the change in gravitational potential energy. Now, so what kind of energy does the pendulum have when it's at point B at the very bottom? Kinetic energy. So it has kinetic energy down here, and that's our initial position, so we'll call it K naught. All right, what does it have up here when it reaches this point A? Yeah, we're going to have to assume it has kinetic energy since we're looking for the speed there, and it has gravitational potential energy. So UG up there. All right, so now let's substitute what we know into our delta E equation, our E equals E naught equation. All right, so we've got K naught plus U naught is equal to K plus U. Now, in part A, we found the delta U, and we can use that because isn't delta U U minus U naught? So couldn't I just subtract U naught from both sides and get a delta U in my equation? So I gotta have K plus U minus U naught, which will be my delta U. All right, so I'm looking for, I'm looking for this kinetic energy right here. This was the initial and this was the final. This one's the one I'm looking for right there. So K naught minus U naught would equal K. All right, so then, okay, initial kinetic energy would be 1/2 mv squared. Oh, what was the mass of this thing? 0.33? And what was the velocity when it was at the lowest point? Was it 2.4 or was it 2.4? Minus, now isn't U minus U naught the delta U? And what was our delta U? 0.72, okay, and that will be equal to 1/2 m 0.33 times v squared. After your ninja algebra, what'd you get? 1.1? Anybody else get that? 1.2. Okay. All right, so now we have the speed. If it had been 0 there, we would have known that it stops, but it's definitely still moving, so you can't assume that it stops. All right, so the next part asks for